use the Tinkercad website here, so tinkercad.com. And we're going to use this website, their circuits, to learn how to wire. This is called a solderless breadboard in real life. And we're going to use wires and the breadboard and a battery to light up an LED. But before we can do it in real life, we need to make it happen on the simulator. So go ahead, you can go to Tinkercad, sign in, circuits, create new circuit. And now we have just a blank slate. Everything you need is over here on the right side. If you add a wire, you can change its color, the type of wire here, and the color here. So the first thing we need, like I said, is our breadboard. So scroll down, take breadboard small out. Now it has a funny name, breadboard, but it is basically just a wired board that allows wires that come in to connect to wires that go out without having to solder them or use melted metal to combine them. We're going to use R to rotate it around vertically, and we're going to take out a 9-volt battery, which I'll also be able to give you to run it yourself. So just to make, so you'll see here, just hit escape. If you click on any of these pins, you'll start a wire, right? And then it'll be complete when it goes to another pin, but hit delete. We're not going to use that one. Quickly, the breadboard is very cool because, there it goes. You have positive and negative that are all in a series. So all the pins here are positive. All of them are negative. So you can plug anything from positive to negative within these 2 rows and they'll be connected. One thing you should know is all electricity flows from positive to negative, and the circuit needs to be completed in order for electricity to actually flow through your circuit. Let's get this started here. So here's our breadboard. Here's our power source, our battery. The first thing we need to do is get our LED that we're going to light up today. So let's take it out. There it is. I'm going to rotate it around so it goes into 2 different rows. I'm going to plug it here into row 15 and row 16. So let's just take a look. So we have cathode, that's going to be for the negative, and anode is for the positive. Let's plug that back in. Now, if we were to run electricity into the positive, so red is positive and black is negative. So now we have a circuit running through from our battery into our 2 power sources, but they're not connected to this LED. So let's go ahead, and we know that positive is going here to 16. So we have positive here out, goes into 16, goes into the LED, but we have nothing returning to go to the negative back to the battery. So let's plug negative here to 15. So now we always going to follow the electricity. So plus, positive, battery, out this way, through the row, out here, into the LED, out there, back to the negative, and back. So it actually crosses over itself. Let's start the simulation. Boom, star. The LED is way too high. It blew out. Oh no, what does that mean? It blew out. Well, because there's the full energy from this 9-volt battery is going straight into that bulb, it burns it out and breaks it. That's important for today. When we start wiring this, we have to put on, let's go stop simulation. We have to now put on a resistor. So you ask, what is a resistor? A resistor actually slows down the electricity. Let's see if I can get one. Do I have an easy S this one? Yeah, here we go. So this is a resistor. You'll get these in real life. Here, this actually, the electricity will flow through here. The resistor itself will actually slow down the voltage or reduce the voltage so that it can be more in control and not burn out the bulb. So let's go ahead and let's delete our positive. Let's take our resistor here. Let's plug it into 16 through 20. And now from 20, we're gonna go to positive. So let's go ahead and follow the flow. So positive from the battery up to here, into row 20, into the terminal 1 of the resistor, up into the LED, out to the negative, and then back to the battery. Now this resistor here is going to slow down our voltage. Let's start our simulation. Boom, our light's on, it works. Great, so now you can go ahead and screenshot this and go ahead and you can copy that into your work. When you have that done, there we go. When that's complete and you post it in your work and click turn in, come up and see me. I'll give you the breadboard, the resistor, the LED, and the wires and the battery to get this started in real life. When you're finished, go ahead and see if you can add a push button. So a push button is like the resistor in the fact that you will actually add it to help finish your circuit. Now, let's go ahead, let's delete this one and put it from here into the negative. Now if I start my simulation, the light does not light up until, oh, it doesn't even light up if I hit that. That's right, because let's follow the circuit. Plus, plus, resistor, LED, out, doesn't go anywhere. We need to have the out go here. Stop simulation. That should work now. Yeah. So the electricity goes out through the LED, up into the push button, out of the push button, back into the battery. When you push the push button, it turns it on. See if you can go ahead and add that push button. See if you can add some more colors. Whatever you make, you can make in real life. Just come up and see me.